can we keep it serverless? So that's the journey we've been on, trying to keep things serverless. So, started with S3. Now the great thing about S3 is that S3 buckets, that's just a file storage system. It put you up your hand if I ever say a technical thing you're not familiar with. This is not a quiz. Well, you know, there is one at the end apparently, but S3 allows you to trigger a Lambda and a bunch of other things, but for our purposes we'll trigger Lambda on arrival of a file. So instantly I start to get a hook into an event-driven serverless platform that can tell me when a file arrived. And that's really powerful because I don't have to write anything other than just listen to those file arrival events. So all of my event-driven stuff is naturally emerging and I don't have a lot of choice actually other than to act event-driven. I can't poll for this stuff as easily. I mean, I could, but why would I? Because I'm getting events. So it forces you to start thinking event-driven and events become a first-class citizen, which is really cool. So that's where we end up with. We end up with an event-driven architecture that can emerge from this. So based on Lambda, Lambda can't necessarily do everything because inevitably, as much as you try not to, you're going to have to maintain state somewhere. So that's where DynamoDB comes in useful. Again, provisioning all that stuff, I want that to be AWS's problem. So I just want to be able to write JSON files somewhere that I can read them again later. I can't do that in my Lambdas. The Lambda's going to die and go away. So it forces me to do it somewhere else, and Dynamo's the most sensible choice. I do get things like a stream to read off of Dynamo if I really want to as well, so I can actually get event-driven from that point. As soon as you write something in Dynamo, you have another event stream you can listen to. Or you can ignore that if you want. It's up to you. So yeah, we've got no service to look after. It's all serverless. Oh yeah, I've got logs. Crap. So where do I write my logs? Oh yeah, and tracing, because now these serverless things are there. I've got a bunch of Lambdas and I lost my trace of my request now because it's across 10 different Lambdas and they all have their own logs. Oh yeah, I've got to deploy these things. And I've got to orchestrate them somehow as well. Oh yeah, and it turns out we need servers anyway because people want to query this stuff and just reading CSVs is no way to do data science. So you've either got to spin up things like Apache Spark or Hadoop and all that kind of stuff, or move stuff into Redshift for people to query. So what we decided to do, and real-time processing, somebody just decided they needed as well. And that's when you're like, oh, screw it, I'm going home. No. There are ways around all of these things, and we're going on that journey. So, first things first, the logging. Because if you can't log, it's all over. You need to be able to log everything you do. So, Service X here, we use Splunk, but whatever fits in here, you can start an ELK stack, or you can aggregate out to some other thing that escapes me that we were talking about instead of Splunk. Doesn't matter. The point is you need all of your logs from all of your different Lambdas going to one place so you can see context across your system roll past you when you go through your logs in order. That's critical. If you don't have that, you're in a lot of trouble. So it is worth investing in some service like Splunk, or at least building your own ELK stack. That starts to get a bit expensive, so there again, so does Splunk. There's no, you don't really, yeah, exactly, it doesn't fix that problem. But it's worth it, because I can tell you what, the time spent trying to go through all the individual Lambda logs, you're going to make back the first incident. Things aren't behaving quite like I thought, and you're going to be really thankful you had Splunk. So it's worth the investment. What helps with that is adding a correlation ID. In other words, when my S3 file first arrives, the first thing that processes the S3 file takes the event, and before it writes it to a log, it adds a correlation ID. And then every other call it makes to any other part of the system, or any event it sends on into an event bus, or any of those kinds of things, it sends on that correlation ID. And the next thing, if it doesn't see a correlation ID, it adds one. But if it sees one, it uses that one and passes it on. So now I've got a correlated ID across every single request through my system, and I can see, oh, S3 file arrived. And all I've got to do now is write that one correlation ID into Splunk, and I see every single thing that happened in my system based on that arrival event, all the way through to getting into a Redshift server. And that is priceless. That saves you time at 3 in the morning. Because nothing ever breaks at 3 in the morning. No. Things only break at 3 in the morning. So, yeah. The other thing is using X-ray. Now, X-ray is a reasonably new thing from AWS. Who's either used or even heard of X-ray before? Great, so a demo would be worthwhile. Let's see if I can make some time. X-ray is really interesting. They've just released Lambda support for X-ray, which is the really exciting bit. It used to just be for EC2 instances and or servers in your data center. Now Lambda supports it as well, and that's really cool. So what that does is the kind of stuff you used to get out of like your instrumentation things, like the thing that I can never remember the name of that everyone uses in their Ruby code or something like that. Sorry, what? New Relic. That's the one. Yeah, my brain doesn't keep that word for some reason. I don't know. It's basically New Relic, but for your Lambdas. Just getting a New Relic agent in there would be really hard. And you get a little visual graph of all the calls, and I'll show you later. It's easier to show you. As for deployments, it turns out that CloudFormation is generally fine. Other people have played with other things like Claudia and Serverless and all those kinds of things. That's great. CloudFormation's been working fine for us. When I say us, I'm talking about my team. Because there's other people in the room who do things differently from MYOB, and that's fine. Right? As long as we don't have it 20 different ways for 10 different ways. That's when you start having problems. But a couple of ways is fine. The orchestration bit. So, who's heard of step functions? So a few people. So step functions is a newer thing that AWS came up with, which is basically state machines as a service. So in other words, I can say I'd like this Lambda to run, and I'd like it to retry 5 times, and when it's done, I'd like those 2 to run, and then when they're both done, I'd like this other one to run, and then I'd like you, if any of those fail, to catch that for after the retries, like 5 times or 10 or whatever, to finally write out to this SNS topic, so I'm going to be listing there. Oops. That's the kind of thing you can do in step functions. You can get logs and stuff. It's a bit raw though. So we've actually taken a step further and we still use step functions for the complicated little flows. Things like, rather than making one Lambda do everything in 5 minutes, we can break it up into little small chunks and give them each 5-minute goes of doing it. Because Lambda can only run for 5 minutes at a time and you're out. So you have to have very small chunks in your Lambda. So if you need to coordinate actions, step functions works great for that. But there's limitations, and if we get questions about it, I'll go into them. I may need a trick first. So, we've actually started using Kinesis as an event bus. It's an architecture that Fred George put up at Yao a couple of years ago. You have this sort of event bus across the top here. Imagine I'm drawing on there. And every single thing that happens, I'm talking about like the DDD style of event, in other words, something happened, right? Past tense. That goes on the event bus. And whatever cares about that event listens to it and says, oh cool, I care about that, I will do this, right? When it's done, it pushes a new event up onto Kinesis. There's only one place it ever needs to know to write. And then anything cares about that event can then go and do its job. And that actually works quite nicely because you can then siphon each of those events out into a Dynamo table. You've got a history of them. You can create a state out of that with a sort of reduced table that looks at the latest event that came in for any given job, all that kind of stuff. And that's evolving right now. Well, they went home, but it'll be evolving again tomorrow morning, right? So, then we're on to the future stuff. So, the future stuff is really exciting. And this, I made Erwin's mind boggle earlier with this stuff, so this is really, really cool. If I can do that, I know it's cool. Yeah. So first of all, the problems with Redshift. Redshift is great for querying a bajillion rows of data all at once, when you actually nearly always need a full table scan and need all the bajillion rows of data somewhere in there, or at least don't care if they're involved in the query. And you need to do that really quick. The problem is that's all it does. It's good at that one thing. It does it really, really well. It's not good at reliability. It's not good at concurrent loads. It's not good at any of that kind of stuff. It's good at reading a lot of stuff really quickly. And there's things about the architecture of Redshift that make that so. A Redshift cluster, so I've got 10 Redshift machines. They're all still only in one availability zone. One availability zone, which means one data center. So in other words, if that data center goes down, I lose my entire cluster, I have to bring it up again somewhere else. And the cluster isn't giving you read bandwidth, or not in the way you would normally think of it. What it does is, it takes, say I've got a gigabyte of data, right, and I load it into my cluster of 10 machines, it'll put 100 megs there, 100 megs there, 100 megs there. It does that for all 10. So it runs the same query across subsets of my data and then aggregates them all back into the master and then sends me my results. So I get 10 times as quick a query because each query is running on a 10th of my data. That's all Redshift does with clustering. There's none of this like replication. There is no replication. It's the opposite of replication. It's dereplication. It's half of my data in each of a two machine cluster. So there's that. Also, you can only load so many files at a time before the machine just falls over. Or you need a really, really, really big machine. And by really, really big, I mean something that costs $6 an hour to run. An hour. Yeah. That's a reasonably big machine. Even then, you're still going to hit limits, right? So, and clustering doesn't help with loading. Remember, clustering's for reading, not for writing. So there's a lot of problems with Redshift if you really want to scale large volumes of data flowing into it. Flowing out of it's okay. So we looked at replacing Redshift with Athena. Now Athena is crazy. Athena is all of that Hadoopy, Sparky kind of EMR kind of stuff the stuff that plays in that space, which is going to an S3 bucket and querying the data in there to do data science-y stuff directly on the CSV files or the JSON files. That's what this is. Only it does it with a SQL client, and you can just connect your JDBC client to it and run SQL directly against an S3 bucket. Yeah, that's pretty cool. It runs a little bit slower than a Redshift server. Redshift is optimized for doing that really quickly. But the point is I don't have to provision the server at all. I just say, hey, I'd like a fake database on top of my S3 bucket, please, Athena. And Athena says, okay, here you go. And I can start writing SQL queries. That's nice. So it gets better though. Because remember I said that real-time stuff people wanted? So the real-time stuff, we're going to go about 5 minutes. The real-time stuff is things like when marketing says, hey, someone's on the web page, I need to know in 10 seconds. And you're like, yeah, the data lake isn't for that. And they're like, I still need to know. And you're like, great. You need something else. So you need to look after those people. That's a real business need. They want to be able to respond to people on a website very quickly. You need streaming events for that. There's no other way around that. So that's where things like Kinesis come into play. So what does AWS do? They release SQL Analytics on Kinesis. So I have JSON structures flying through Kinesis on a bus, firing at me. It's just single events with data in them. SQL Analytics lets you create a schema by flattening out that data with JSON path, and then write SQL queries on this actual JSON structures flying through in the stream. SQL queries on a live stream of data. Yeah, that's nuts. That's more nuts than a thing. That's just totally insane. That means that I can actually do my data science before I even have it in the data lake if I really want. I can be like really preliminary, I have no idea what's coming through this stream. I don't know, well, let's go find out. And you can do joins, and you can do all that other stuff in SQL on a stream of friggin' data. Yeah, right. And then you've got Firehose. So once you've done the analytics, oh, by the way, there was no code involved in this. It was just a SQL query. Literally zero code, no lambdas, no nothing, just a SQL query. Oh, and a little schema definition, which is just press the button and it just figures it out for you anyway. Firehose is, okay, once I've got data in a stream, I might want to take that stream and put it in the data lake in my S3 buckets. So Firehose does that automatically with zero coding. You basically say, here, take this stream out of SQL Analytics, and there's a connector directly from Analytics into Firehose, because the Analytics is a streaming pump-based thing, right? So I pump the data into my destination stream, and my destination stream pumps it into Firehose. And Firehose says, okay, I'm going to sit here and wait for 5 minutes or a couple of megs of data or whatever you configure, right? It's up to you. You could be down to 1 minute and like very small bits of data if you want. I'll sit here, accumulate those rows, then I'll write them out in a CSV into this bucket for you as a service. Zero code. So my job's slowly becoming redundant. I just sit here and just sort of tell services to do stuff, and I write the code in. That's not really true, but I could. Which you could, doesn't mean you should. Anyway, so this is a way of getting things going very quickly to be able to just analyze data without having to write the code. That's really the point here. If you do that, you can get the beginnings of your data analysis happening very quickly, and then you can say, oh good, now that we know what we actually needed from our data, you can go get the data you actually need, and then treat it more properly via code, via jobs in EMR or whatever it is you need to do with them. You can let the data scientists go nuts in any of those places, right? And then what we're really about for the data lake is being able to then take those data sets, make more data sets by combining them, and then shipping those out to web services to be able to use. And instead of hitting our data lake, what they do is they export that data into another S3 bucket of their own that they can then rely on. That's like the hipster batch kind of thing. Because they can't rely on Redshift at all, it's single AZ. If I hooked a front-facing service, someone came to a MyOb website, MYOB website, let's stop saying MyOb, and they were depending on a web service that was hooked up to my Redshift server, I'd be mortified. So I couldn't give them an uptime guarantee. I can pretty much give them a downtime guarantee, actually. This is single AZ. There's no way I can say that's resilient. What I can do is I can ship out to S3, and apart from a very famous recent incident in S3, S3 is pretty robust. And they pretty much blew every 9 in that robustness in that last incident. So it's going to be perfect from now on, right? Yeah, the numbers say so. There weren't any references, as it turns out. So, questions? I'll go back to the front. Actually, no. We should always be future looking, right? So I'll just go back to the what's I like the future. Yes, questions, yes.
The data is not normalized. And you're not with raw CSVs into it.
I'll have a normalizing job if I need it. I can do things like looking up linking IDs. We actually have that kind of thing where we're going to have telemetry flying in that has no identifying info in it. Thank goodness, because PII, right? And then, so the PII needs to be linked somewhere else, and I need to then probably reduce that into something else somewhere. I'll just take all the data and I'll have another job that joins it all up later or whatever I need to do. That's worked out really well because I can smell the pizza now. There was this sort of metric, when you can smell the pizza you need to stop. That's just happened, so that was perfect, yeah. Did that help? Yeah. Just give me the data as it is and I'll deal with it later. That's the mentality. Sure.
Sorry, you talked about various bits and pieces of your system. Could you possibly say, like, if I have a 100 gig file, which is CSV, and I put it into the system, can you take us through?
That's pretty funny. So if you give me a 100 gig file, everything breaks because I've got a 5-minute Lambda limit and also size limits in my Lambda, and it's not going to even be able to process it in the right time, probably, is my, because we take zip files and we unzip them, and so that's got to.
So if I give you a file.
Theoretically, we have a file that can fit, exactly, yeah. So we are going to solve that problem, by the way, but yeah, take the file. So it arrives in S3. So there's an S3 arrived event. Currently we're sort of moving between two systems. I can describe the old one really well. There's a bounded context for ingestion. So the file arrives in a zip, it gets unzipped. We, at that point, haven't yet, could check for like headers to make sure they match the definition of the file we're expecting and do like error correction and stuff. We haven't done yet. You can also mask PII at that point and then delete the original. So there's an ingestion context there that is one set of things before it even hits permanent storage for a data lake. It's like minor cleanups because I even don't want to store it if it doesn't like meet these criteria. Once ingestion has happened, an event gets generated that gets over to the job processing stuff, and the job processing stuff looks up and says, oh yeah, you want to copy that data into Redshift and also send it on an SNS topic, row by row, to this other team who actually wanted events, but they only had batches as their source data. We do that, right? So the job system says, okay, I'm going to start a copy job in Redshift, so it goes to Redshift, takes the S3 file, and does a Redshift copy command that pulls the S3 file into Redshift. When that's done, it says, I'm done on an SNS topic. the listener on the SNS topic says, oh cool, I'll look up another job. I'll tell the job system to look up another job. So it does, it tells it, oh yeah, cool. So there's another job that should run in this chain of jobs, and that job goes and grabs the file and says, oh cool, there's an SNS topic over there, this other team are listening on. I'll take the file that you sent me, split it up row by row, and emit each row as a packet of JSON onto that SNS topic. So that's one of the flows that we have. That answers the question, it's the kind of thing? Yeah. What we want to go to is, data comes in, and we have a job that says, yeah, I need 4 of these files combined, I want to select these rows and combine them and add that other data set and make a new data asset out of that. What we're about is creating data assets. That's the language we like to use. Enriching data with other data to make it useful for a data scientist. They don't have to do all that work. It's already done. They can go in and answer questions. What would happen if people did this question? Bam, they could go to data science. Is anybody interested? I know there's pizza, so feel free to say no. Is anybody interested in very quickly having a look at what X-ray looks like?
Yeah.
Okay, right, yeah. So all the people who wanted pizza, you can just hate on the other people and that's fine. So,
just because 2 people said yes.
Yeah, exactly. Yeah. That was enough for me. I'm not going to be asking for.
I was one of the 2 that I don't mind.
Yeah, well, that works out fine. Let me just do this while I'm logging in.
James, while you are logging in, I just want to say that we have 2 types of people. Well, actually, there are more than 2 types. But we have vegetarian people on the white table and non-vegetarian people on the other table. So once we finish, yeah.
This won't be long.
No,
Yeah.
okay.
All right, I think we're in. Hopefully the screen comes back. This is always the interesting moment. Good enough. Okay. Afraid to type now. So, X-ray. I'm just going to, I haven't checked this before, I'm assuming we still have decent service maps in here. Oh, we do, good. Oh, nice, it's nice and complicated, excellent. That's what I was going for. So, what I get here is, client calls some kind of AWS service. In our case, this was the thing that looks for those child jobs. You know, I said there was like, the copy finished and then another job happens. There's a listener on there that looks for that second job, this is it. So it says, as triggered by SNS, so that's that client here is the SNS topic. It gets triggered and says, oh cool, I'll go and notify the thing that had that job. So this is where we're in, SNS notify, that's the SNS thing that we were talking about. And then you've got all of the other calls going on in here with their average times, and I can see the whole map of my twisted web of microservices all calling each other, and I get to see it visually. That's actually quite useful to understand what's really going on in your system, right? Better than documentation, right? Because documentation is garbage. This is really happening, or at least it was 5 minutes ago, according to this. So, the cool thing is, that's not all I get, because I can do that. And I get a full trace of everything that went on in there in terms of the AWS calls and how long it all took. So I can see I've called SNS and Dynamo and S3 and another Lambda, and then I did more S3 and all that stuff all happens in there. And I get timings for it all, and then I can do all the profiling I would get out of something like New Relic and that kind of thing. The code to do that instrumentation is pretty torturous. And anybody who knows me now knows that was my sarcastic voice. It's actually, I'm going to use an SE, that'll do. No, that's not it. Here we go. Wrapping the board and that. Oh no, it'll be one of these things. Sorry, just give me a second. We're almost there. You've been very patient. Congratulations. Yeah, that's it. That code there automatically instruments the entire AWS SDK for me transparently, and my tests didn't even break when I put that in there because it's so transparent, my tests don't even know it's not just the AWS SDK. And all of those calls that you see instrumented there, it just happens in the background automatically without me lifting a finger. So that's what you get out of serverless when you go AWS. You have to do a lot less. That's it. All right. I hope that was useful, folks. And you can always ask me questions later.